In the last part of this presentation, we were discussing the various buses on the computer, and we discussed how there are a number of different buses called the local I/O bus, memory bus, and internal bus, and we were talking about portions of those buses. Each of those buses can have both a data and address bus associated with them. So, for example, the local bus has both data and address information as well as control signals. The I/O bus has data, address, and control signals. The memory bus, data, address, and control signals. And the internal bus inside the CPUs would have data, address, and control signals. So when I talk about a data bus, I'm not referring to any one of those. I'm talking about all of them. All of them have both data flowing across some of the wires, which would be considered a data bus, and wires that have signals that select an individual memory location or device. So a data bus and an address bus will be part of a larger bus, as well as control signals, which would tell whether something's being read from or written to or being interrupted, things of this nature. Now, to understand a bus, it's helpful to look at an old computer. This was a computer that I used when I was in high school, and it's quite famous now. It was famous because it appeared in a movie in the 1980s called War Games, in which a computer tried to take over the missiles from the Army. But it was a pretty neat computer because it had a display on it that showed you the bus between the CPU and the memory. You could look at it. That would be considered like the memory bus in today's PCs. It showed the data bus of the memory bus, and it also showed the address bus of the memory bus. This particular computer had an 8-bit data bus, like the original IBM PC, and it had a 16-bit address bus. And you could actually see the data, the ons and offs, represented by, or zeros and ones represented by the lights. If the light was on, that represented a 1. If the light was off, it would represent a 0. So in this particular picture here, we could figure out what was on the data data bus and what address it was going to by looking at the lights. So right now we can see that these lights are on here, and this number here we would calculate by adding up the binary places. This would be the bit, they call this bit 0, bit 1, bit 2, bit 3, bit 4, bit 5, bit 6, and bit 7. Bit 0 has a place value of 1, so we'd have 1, 1, we'd have 1, 2, we'd have 1, 4, 8, 16, 32, 64, and 128th place. So you'd light up, you would count the places that had the lights on. So we would say that we would have 1, 1, 1, 2, 1, 4, 1, 8, 1, 16, 1, 32. You would add those up, and that would give you a total of 63. So this number here represents the number 63. 63 decimal, or you could break it into groups of 4, in which case this upper group here would be 0, 0, 1, 1 binary, which translates to the hexadecimal digit 3, or binary digit 0, 0, 1, 1 equals 3 decimal also. And then on the rightmost half of the byte here we have the 4 more bits. By the way, 4 bits is called a nibble. Half of a byte is called a nibble. So this would be the leftmost, the higher, most significant nibble, and this would be the less significant nibble. And this has 1, 1, 1, 1 in it, and so that's the number 15 in decimal, which is F in hexadecimal. So this number would be 3F hex, 3F hex, which would be equal to 63 decimal. And that number is going to go either into or out of a memory location. And it says right now it's memory read here. This light tells us it's reading the memory. So that's actually coming out of a memory location at the moment. It's being read. So what was neat about this computer is you could actually watch it running. And it was kind of fun to see. That's something I kind of miss about today's PCs. You don't see that anything going on inside. And of course they run so fast that even if they did have lights, they would just be a blur. And this thing ran at a relatively slow speed of around 1 or 2 megahertz, million cycles per second, which was pretty fast in those days, but today it's not considered to be a very fast computer. But it could do a lot of things. What's kind of neat is here I have a simulator that runs that will demonstrate the operation of that computer. Here's that simulator. This is a program that you can download, and it's a simulator of it, and I'm running it here on my computer. I'm running Linux right now, as a matter of fact, and it's running as it's actually a Windows program, but it runs fine in Linux under the Wine emulator system. But actually it's not running as an emulator, it's running at full speed, but anyway, it runs. That's what is important. And it runs programs. And if we flip this on here, we can turn this on. Let's see, here we go, it's on. I guess it was already on, wasn't it? And then I can what I can do is there's another button called Run, and I'll run it now. And see there, it's what it looks like when it's running. You can see the lights blinking and flashing around. So we're noticing that the addresses change and the data is changing. That's because as it's going through its program, it's fetching and writing data from the memory, from and to the memory, and according to the programs that are stored in that memory. And that's, you know, you see that happening. It's kind of interesting if you stop the program and then you can step it one at a time. With one of the switches here, you can see it execute it one instruction at a time and see how that each of those instructions, I don't know what the instructions are, but sometimes the instructions are what's coming off on the data bus, and other times it's data that's being manipulated. But I just thought that was kind of interesting to show you there, that you can actually see the data bus and the address bus on these older computers. Here's another famous computer. This was the Altair 8800. It was the world's first personal computer. It was introduced in around 1975 as a kit and became quite popular. The company that produced it was from New Mexico. It was called MITS, or MITS. By the way, the very first product that Microsoft sold, which Bill Gates started, of course, was a program for the Altair 8800, a programming language, a version of BASIC, and that's really the computer that got Microsoft started also. Here's another. This was the second computer that company produced. It was called the Altair 8800B. It looks very similar, just a little more modern looking case, but very similar in many ways. And I have a little emulator for it too, and there you can see it running. It is the same kind of, let me clear the screen here for a second, put it back there. You can see the lights blinking, and it too has a data bus here that's signified by these lights and an address bus. Let's see, the data bus is here on the top right here, these lights, and it's labeled D0 through D7, and then you have your address bus, which is A0 through A15, or in other words, it has 16-bit address bus. And it had these switches, and the reason for the switches was that you could toggle in data to be stored in the memory. And you could do that with those switches. You would have to actually toggle in the data by flipping these switches up and down like this. And then you would set a switch. I'd have to stop this first here to do that, so we'll stop the thing from running. But what I would do is, let's say I wanted to put this particular byte in there. This would be 11010110. If I wanted to put that into the memory, what I would first do is I would set up my address to do that. And so flip up some switches here. Let's say that's my address. And then I would tell it to deposit the byte into a particular location. And then that would be placed in that location. And then each time I do that, I have to do that for each individual byte. So it was very tedious. You'd have to toggle in every single byte into the program. And it might take you an hour just to toggle in a few hundred bytes, a few bytes to get the thing started. We had at my school a paper tape reader, which was a device with little holes in a paper tape. Once you got a little bootstrap program loaded in there by toggling it in, then you could use the paper tape reader to feed in a larger program. So let's say you wanted to program it in BASIC. Well, you could get a paper tape that had BASIC on it. You had to toggle in a little starter program, though, to begin with. Later on, we added an erasable programmable read-only memory, or EEPROM. Basically, we put the bootstrap loader on the EEPROM, and then we didn't have to toggle it in every time we turned on the computer, which was a pain. So that meant that the computer would start up and had its own program built in then, kind of like the BIOS on today's PC, except it didn't do a power-on self-test or anything like that. But then you could just turn it on and run it paper tape through, and it would immediately be ready to run. So anyway, a little history there, and much of the idea that was incorporated in these early machines we still have today, especially the idea of buses. In fact, the original IBM PC had an 8-bit bus, but it had a 20-bit data bus. So it had a bigger data bus than those other computers I was just showing you, which meant that it could address more memory. The Altair 8800, for example, it could handle up to 64 K bytes. That would be kilobytes, because it had a 16-bit address bus. If you take 2 to the 16th power, that'll be 65,536. Well, by using 20 bits, the IBM PC could handle 16 times as much memory, or about over 1 megabyte. So in its day, it was considered to have a very large memory, and as a result of that, it could run much larger programs or handle larger data structures than would the 64K computers. The IBM PC's motherboard, you could clearly see the bus, and that would be these slots here. And you could see the wires running between these slots. So it was very easy to make out a bus on that system. And today you still can see some of those same wires on a motherboard, although they're a bit more hidden.